I'm Alex. I'm a senior solution architect at Amazon Web Services, and I work mostly with software vendors across Europe, Switzerland, Germany, and I have a good friend with me.
Salut, je m'appelle Benjamin. I am front-end engineering team lead at Funke Mediengruppe. We are one of Germany's largest publishing houses, and my team and I focus mainly on building the platform for quality national and local news. So you may wonder, what are these two guys doing here together on stage? They're not even from the same company, but it doesn't matter. We are going to present to you today a concept that can solve general problems in larger web applications. And it's not just a concept or a nice thought play. We have actually delivered this before to a large web application that can serve hundreds of thousands of customers per year. So welcome to our talk on native web technologies in distributed front-end architectures.
Thanks, Benny. So the case we want to present here is the idea of a large-scale web application. In that case, it might be a flight booking website. And you see here you have the search bar. So you may be working with a large team or multiple teams on that, and they of course all want to deliver value. They are maybe working on the same code base, but in the end it might be a bottleneck that they need to deliver through all the same tooling. That kind of problem is not new. We have seen this in the backends for years, and there are solutions to that through distributed architectures such as microservices. And wouldn't it be nice if we could apply the same principles that we use in the backend and the frontend as well? Because frontend is complicated these days. It's quite complex in terms of state management, authentication, authorization, and the entire logic of the workflow from end to end and error handling. So there is a need to distribute that and kind of streamline it along the delivery as well. And we can indeed do that. So the way of slicing applications along, let's say, context boundaries is possible here as well. Of course, there's still the question of where do you slice and how do you integrate it then, both in terms of composition as well as orchestration. But there's an architectural approach to that is called micro-frontends. And this is what we're going to call today. As Benny said, we have delivered it at scale in an application that serves hundreds of thousands of customers regularly. So this sounds like it is a mere front-end topic, but in order to understand the underlying concepts, I'd like to go into the architecture of that from a component level. Historically, many applications start with a monolith, which is fine because, monolith is the right thing at the beginning of a new application. You can go fast without thinking about interfaces and integrations. But eventually, as these applications evolve, organizations get larger, they tend to extract the logic, that is the backend, the business logic, into separated services in the backend, like microservices, and they would expose them through a GraphQL or API REST layer, which is a natural evolution. At some point, the organization may want to use all these fancy new technologies, so they want to build the UI in CI/CD and not have it generated every time through, I don't know, PHP or whatever. So they go into a single-page application approach and would have a static website. What is important in that architecture is that you still need something that fetches data from the actual deep services in the domains, and that is the so-called backend for front-end. The backend for front is very important in that architecture because you don't want the client-side code go directly to your REST or GraphQL services because of performance, authentication, but also because the logic of the backend contains data in a format and the semantics that speak the domain backend language. So let's say order or payment. Whereas in the front end, you need to follow UI logic. You need something that would be aggregated from different sources or even transformed. And so you have this little layer that acts as this aggregated transformer and is deployed here. So that is a very common architecture these days for mid-sized and sometimes larger applications. But we have a problem here, and that is to deliver new capabilities, we may need to go through all these layers in order to bring those features to customers. And in order to address that and to align the technical architecture with the business logic, we need to rethink the entire web architecture. Excuse me. So what we do is we carve out the entire thing and start from scratch. First, we will have a little layer that still needs to integrate. We need to bring things together, but this is just a scaffold to bring components together, and it will be used as an orchestrator. And then the actual UI logic and interface will be delivered to a so-called web component, which is a UI building block, but also contains more than just the visuals. It also contains, state and logic within its scope. And this will then integrate with the app shell layer and talk to other components. With this web component together, we would have its own BFF. So we also use a BFF here because, again, we don't want the web component to go to the API directly, but it has a private BFF, only for its own purposes, very, very lightweight code. And the BFF would be allowed to then go to the backends. This together, this kind of tandem of a little full stack that lives in the web domain, both on the client and the server side, is what we call a micro frontend. So looking back at our flight search page, this would be this flight form, let's say. And we could have another micro frontend there. It would be the, let's say, result list, and they can talk to each other through this integration orchestration layer. In a typical web application, you may have tens or even dozens, and for the entire website, maybe even hundreds of micro frontends in very different shapes or forms, but they would all follow these principles. So there might be a micro frontend that doesn't even talk to the deep services in the domains. It might be self-contained. It still has maybe a little database or cache with itself. And there might be a web component that doesn't need any of that. Of course, if it needs to go to the APIs, it will need this kind of translation layer. So that is important conceptually to understand that this is not just front-end components, as many people might think, just a bit of React thrown together and then we do some magic to decouple that. But this is really a full-stack web architecture that has self-contained business components. So you may wonder, so if I'm a team now, and we said we could align this with the delivery of teams, how could you build such a thing? Looking into the deployment infrastructure, we'd first see that this kind of self-contained full-stack service would be similar as, let's say, a microservice, contain all the runtime code, but also the CI/CD and the infrastructure as code, so the description of its runtime environment within one repository. So you have the logic all in, it could be owned by one team. In order to deploy that, you could use a simple container-based architecture, so you could put this in one or two containers, where one would be a static web server serving the web component with all its HTML, CSS, JavaScript, and so on. And for the BFF, you would use a little application server such as Node.js. So that is completely possible. There's different ways. Me being kind of a fan of serverless architecture and very specific components, and being at AWS, I like these kinds of building blocks, and you would deploy the front end into an object storage, expose it through a CDN, and then in the backend, obviously, you would have some sort of compute unit like AWS Lambda or any other similar service. You would expose it through the API gateway, and as mentioned, you can have all types of other building blocks within that scope that fit the purpose of that micro frontend. How do you deliver that? How do you build and deploy that? Is very similar again to microservice architecture. So you have that self-contained repository, and during the CI/CD, you would simply first build the artifacts, so the front-end web component part, typically using some NPM-based build process. You would build the backend, depending on the language. This can be anything that the team likes. Typically, Node.js is quite well suited, but it can be Java, Python, whatever you want to have at that little backend for front-end part. As soon as the artifacts are built and tested and you are confident in their quality, you can go ahead, deploy the infrastructure, either create it or update it, and then finally place the components into the architecture. And the micro frontend will be functional as a service that can be kind of consumed by the website. The consumption, so coming back to this example, would work here in a way that you could pull the individual front-end components that are deployed in the CDN into the web page through just a JavaScript include. And as soon as they need to get data or interact with some sort of backend functionality, either in their own stack or something that is a third-party API or some domain services, they would go back to their individual API gateway and be able to fetch that. You could also go ahead and say, for purposes of security, observability, you might go ahead and extract the CDN into a central one, same with the API gateway. And then the front-end components would be registered in the CDN. The web page would pull them from the CDN through the registered routes. And likewise, to access the backend for frontends, the individual components would go through a central API gateway. and this would then route to the backends for frontends. So this is gradually, I hope you think where we're getting, so this is quite an elaborate architecture. I'm not saying this is suited for every kind of application, but if you're at the point that you're building this at enterprise scale, this is a trade-off of complexity versus autonomy and parallelization that helps teams. There's one caveat though, and when you build such a distributed architecture, it's very easy to fall into a trap of coupling things too tightly together. And this is why when we talk about integrating those components and having communicate, we will need to talk about really giving it the autonomy and avoiding coupling. And this is where I'd like to do a little kind of excursion into event-driven architecture. So I'm going to talk a bit theoretically about what it means, but it all fits together into the part where we will see how it's implemented, and you will see why we are doing things the way we do over there. So teams or engineers, when they first come from building synchronous services into microservices, they tend to create tight coupling. Coupling itself is not necessarily bad. So things need to come together in some way, so you need to couple, integrate them in some way. But if you are not aware of the different types of poor coupling, you are creating dependencies that make your architecture brittle and fragile. So if we drill deeper down, what tight coupling could mean is there are different types. So for example, there could be location coupling. You might create a dependency of one service that needs to know where other services are, and if they change their location, the integration will break. There is temporal coupling, which is the most common one, where you build services that only talk in a synchronous way, and you expect an immediate response in order to progress. There's semantic coupling. This means that you would expect data and messages to come through in a predefined format, and if the semantics or structures change, then again the integration will break. And finally, the most complex type of coupling is the sequence coupling, which means that if you put the logic of what happens when into those services, they are strictly bound to executing things in a certain order, and if you need to exchange or adapt that, the whole workflow will break. So these are typical pitfalls of distributed architectures in early stages, and I want to show how you can avoid them. And this is, by the way, not only front-end, this is a typical back-end architecture pattern as well. So the first thing we can introduce here in order to decouple in a localized and a temporal way is introduce a so-called message broker, where we say we do not talk directly between services, but we introduce a channel that allows us to push messages around. And this is the first step towards solving location coupling. We don't need to know where everything is, we just need to know where the broker is. And we say we don't care what happens directly with that. It introduces a bit more complexity, but we can say we can work without getting an immediate response. The little problem here is just putting messages on a broker has everything commute to everything else, and you don't want that. So what you need to also introduce is a way of knowing who gets what messages. And one way to do that is a publish-subscribe mechanism. The way this works, and probably many of you know that, is that the consuming service knows that it is interested in certain messages, and it could go to the broker and say, I need to have that message, and the broker will make sure that it's being propagated correctly to the right service. Now, again, this helps us with some types of coupling, but still we have the problem of the semantic coupling, because the messages need to be understood by both sides. And we still have the sequence coupling, where the order of things happening is still in the ownership of individual services. And if they change their place in a sequence, things will break. In order to resolve that, we need to go a bit deeper into what message means. And again, coming from more synchronous architectures, engineers are used to execute commands against other services. So the calling service would tell another service what to do and expect this to happen before it gets a response or result back. But in a temporally coupled architecture, this is not useful, because in the moment you send a message, you don't even know where it's going and cannot expect some things to happen in a certain sequence. So this is not event-based or event-driven. So we want this to be actually an event. In order to tell other services what we expect from them, we turn this around. We say, we tell you what I did, and you can act upon that. And this is what you would do again with publish subscribe. You would consume the event that you are interested in order to act upon that. So we are getting somewhere into resolving the sequence and semantic coupling, but we're not still there yet. So let's introduce another element that will help us to overcome these challenges as well, and this is a so-called orchestrator. The orchestrator is the element that has two functions. First, it owns the workflow. Not one of the services knows what needs to happen next or when and how to handle errors, but this is all done by the orchestrator as a dedicated service. And secondly, it acts as a translator. So the message semantics coming from the producing services will be translated in the ones expected by the consuming services. And this is the way to decouple also from a sequence and semantic perspective, and this is what we're going to do today. So what effectively happens is the orchestrator knows that there's a search event coming and can subscribe to that instead of the result list, so it will get the search event. And once it catches that, it knows also that the result list is expecting an update event of some sort, which would contain the new configuration that it should kind of adopt. And it can then forward that part of a kind of event in an imperative or declarative way. So in this case, I've chosen a declarative way where you would have an object describing the expected state and can forward this. And ultimately, this leads to a full ownership of the semantics by the service in its own scope. So you have a bit more complexity here, but each service owns both the produced message semantics as well as the expected message semantics. So that has been a bit of theory, and now I want like to hand over to Benny, who will go with you through the implementation of all that.
Thanks. So now that we have our concepts in place for the distributed architecture and the infrastructure and also our communication patterns, we have another challenge to solve: how to actually make this work in the browser. And let's just assume we have a simple web page here. And this is basic HTML, but we already have two micro frontends here. And you may wonder, where are they? They are right here, just 2 lines of code each. The first line of each block is a so-called custom element. And if you haven't heard of custom elements before, or web components, they are just basic HTML tags that you can define yourself. They can have their own sub-elements, styling, even logic. And they are native browser technology. So if you have attended Bartosch's talk yesterday about the power of simplicity, this is the concept right here. You do not need any framework to build microfrontends in the browser. It's all there for years now. It is simple, and you can define self-contained components. The second line of each block is the definition file of the custom element. So let's see some code. This is the definition of a custom element. You can register your HTML tag with the browser by using the custom elements define API, register it to a component registry, and you just hand it over the HTML tag name that you wanted to use, and then you extend the HTML tag class to get basic functionality of HTML tags. Now, every time the browser comes along this HTML tag, it knows what to do. It triggers lifecycle methods to render the component. One of this lifecycle methods is the connected callback handler. Here you have some code. For the sake of our talk, it's not much code, but in the real world, this can be a pretty massive amount of code. But what we have here is our form. If you remember the search form for the flights, departure date, departure airport, the numbers of person you want to travel with, and so on, this can be implemented here. You can also use basic browser technology and tags, which, for example, have great accessibility features. And also, you have your styling here to make everything look nice, have a nice user experience. Now we have our, display, our representation, our visual representation, but what we also need is some sorts of communication. And for inbound communication, we have a standard of using attributes. So from the outside, they're just basic HTML attributes, and you can define in your custom element which attributes you want to react to. So you just register them, and then every time a change happens to these attributes, you have your attribute changed callback handler. And there you can react to the updates, do some logic, and so on. And this is some means of inbound communication. The other standard of communication is, of course, outbound communication. So we want to send information out of our micro front end, and for this we can use events. I guess all of you have heard of standard browser events such as the click event or even the submit event of a form. And we are going to use the submit event, but what we are also going to do to send information out is create a synthetic event with the create custom events. Again, native browser technology. So once we have fetched our submit event from the form when the user has put in the data for the flight, we extract the information from the form, create an event, and send it to the outside world. We have to make sure it can leave our contained context by setting compose to true and let it bubble up the DOM tree, and then we have the information out. This means with this very simple approach, we have a visual representation and we have inbound and outbound communication with just a few lines of code and no framework. If we go back to the main web page, we can see that we already have some data for the inbound attributes. This is some initial configuration that you can render on your server, and in this case, it will just give us the basic language for micro frontend. In the real world, this can be, of course, many more attributes. Now it gets interesting. If you remember what Alex just said, we have an integration layer, and this is our means to decouple the micro frontends in the browser. Just a few lines of code, but they serve for a great pattern. What we do here is we listen for this synthetic event of the search form submit. If we remember, there are the search flight data, departure airport, and so on. And we take this data, and our orchestrator takes this information and passes it on to the result lists. So no deep object handover. The orchestrator knows the information and hands it over to our result list. This is just done by setting the attributes. It's as simple as that. So we have our departure airport and the date as attributes for our result list micro frontend. Now the attribute changed callback handler of the result micro frontend can handle this information, hit the API, the backend for frontend, request the flights, present them, and we have a nice user experience without the two web components interacting directly with each other. So the point here is we have a decoupled front-end setup. And this is a great way of enabling teams to build their own micro front-ends without depending on each other. Of course, with every distributed system, the autonomy can lead to chaos. And quite frankly, I've seen this quite some times when teams start out with micro front ends, that they try to circumvent the integration layer, or they request some deep data model changes from another team. And even though it's great to talk to your partner teams, this can be very cumbersome. And we have to have some sorts of contract or event API specification. And I guess some of you know the Open API standard, which is a great way of describing REST APIs. And what I would like to show you today is the Open MFE standard for Open Microfront standard. And it's also just manifest files. A manifest file can describe your micro frontend, and it has certain paragraphs or parts. And the first part is mainly intended for the human reader. It gives you context about the micro frontend, even for maybe not so technical personnel. And also, it can be used to auto-generate documentation, right? If you have big teams, a big organization, there will be lots of micro frontends. So a human readable documentation is really needed to deliver value really fast. The next interesting part, of course, gives you the HTML tag name. This is what you need to integrate the micro frontend into your HTML page. And it also features the URL where to get the definition code, of course, which you can use for automated integration, automated testing, and all the stuff that DevOps engineers like. One big chunk, of course, is our actual data contract. And this is really important. Every attribute that the microfront can consume, every event it sends out, has to be described here. And not only the name and some sorts of description so the other teams know how to use it, but mostly also the data structure. And for this, we can use JSON schema. So don't be confused. This is a YAML file. YAML is a superset of JSON. JSON schema itself can't take comments, so there's certain stuff you have to look out for. But basically, every argument for the interface and every event for the interface has to be described here. Speaking of having to look at some things and how to use this, the OpenMFE has a nice web page where you can read more about the concepts and repositories and so on, and we will link this at the end of the talk. That's the page, and you will get the link on the last slide. Now we have this nice way of communicating, presenting things, and mostly decoupling. And you know, the real world is not only fun and games, it's not always developing software systems on the green field, as I guess all of us know. What we see in the real world is, quite frankly, and often legacy systems that need to be replaced or modernized, and micro-frontends are a great way to do so. Let's assume we have a large web application of a bigger organization with lots of distributed teams, lots of business critical capabilities, and for some reason you have to modernize it. What can you probably do to do so? Of course, you can build the thing, have a big bang approach, switch over, but this might not be a good idea because the teams have to maintain the old system, build a new system, which is double the effort at some point. Also, there might be some, you know, if a system matures, you learn about the system, you know what to fix, how it behaves, you know all the tweaks. And if you start with a new system, it has to mature. And if you have a big switch, you might lose some revenue. So why not do it incrementally? And micro-frontends are a great way to do so. We can just build certain new features or verticals with micro-frontends and then retrofit them into the old platform. And this is where the native technology comes into play, because we just use native browser technology, and this fits into almost every front-end stack. Java server facades, every framework you know. So this is a good fit, and this is a very great benefit of open technology. If you have developed your micro-frontends, if you have battle-proven them in production, you can, on the sideline, create your new website. This shouldn't be too much work because all the business capabilities, the logic is inside the micro-frontends. And once you have got some, feeling for your micro-frontend and it's proven to work in production, you can switch it over to your new site. And just one thing that is important for that, if you have a design system and a UI library that can serve the old design, the new design, this really helps. And let me tell you, web components are also a great approach for this case, but this is just, the tipping on the ice. So now we have seen a great way of decoupling front-end and large web applications through a stack, through the sorts of communication, how to do it in the front end, and even use an open standard for that. And if you want to learn more, maybe about the concept, see some example code, some tooling on how to verify the manifest files, you can scan the QR code. I hope it's big enough. And if you have any questions and if we have time, please ask right away or talk to us after, outside, or whatever. We would really like to talk to you. If you like to talk, please give us a rating. Would really mean a lot. Thank you so much for being here today. Thank you so much to DevOps Days Genoa. It was a great pleasure. Have a great rest of the day. Thank you very much.